3,000 years ago in Assyria, someone has the idea of creating a map describing us versus them. And over time, things have changed in maps. Maps have evolved from being just a depiction of the world as we understand it, to a tool for navigation in the 16th century with Mercator, to then, in the 19th century, a second important disruption, which was made by a certain Minard, Mr. Minard in France in 1869, had the idea of adding quantitative data to a map. So he took a map, a geospatial information. Left is Paris, right is Moscow, and this map shows the progression of Napoleon's army from Paris, or from France, where there were about 500,000 soldiers, leaving to Moscow, and as they move to Moscow, you see the line getting thinner. And after sacking and burning Moscow, well, the retreat starts, and that's the black line, and you see that the number of soldiers that actually returned to France at the end was about 10,000. So that's a loss of 490,000 soldiers on 500. Today, this would not be acceptable, but the point from our business perspective here is that this Mr. Minard had the great idea of adding quantitative information to geospatial data. Quantitative information, not just the number of soldiers, but also here below the temperatures during the retreat. So and you see that when they cross the famous Berezina River, which is still in French word for a synonym for disaster, well, when the Napoleon's army crossed the Berezina, they lost about 20,000 soldiers, and it was minus 20 degrees. When they crossed the river, they froze to death. Or were killed by the Cossacks. So this is really a disruption going from the us versus them and let's use maps to navigate to add quantitative information to a map. Now what we've done since then is we've invented computers. Well, computers are great to automate what Minard invented in 1869 and what the Assyrians had done before with clay tablets, but actually it doesn't change the business model. It's still exactly the same thing. It's just more accurate and faster. I think that, and we at LUCIAD, we believe, like some of the other speakers, that the real disruption comes with the amounts of data that are produced today that include location information. You have now every cell phone or smartphone that we have, and there are 2 billion of them, produces information. Philips lamps produce information. All that information has a geospatial content. And so we now are confronted with big data, which if we try to interpret it as geospatial information will create issues. I mean, the databases or the geospatial databases are not made or were not designed to incorporate that type of information, which is very high volume and changes very fast. If we try to put everything in a geospatial model, well, our silos are going to break when the geospatial databases are not designed for that. So what we are proposing and what we started proposing about 15 years ago to the military industry, which was our defense agencies, which are our first clients, is a model where you actually connect data to the visualization through an in-memory model. And in order to do that, you have a few, I mean, we're not a services company, really, we're a technology company, so these are a few technical terms. Cloud infrastructure is a way of solving the issue. Another speaker talked about gamification is a way of solving the issue. Technically, it's massively parallel processing, where you use thousands or hundreds of thousands of computers and millions of cores to solve an issue. Very important, and especially I think in this forum, very important to talk about open standards for exchanging information, storing information, and many other aspects of the technology that we had to deal with in order to be able to help work through that disruption of big data in the thing. One of the some of the toughest issues have to do with the fact that the data is asynchronous. You have things that are static, a map. You just mentioned the cycles for infrastructure which span dozens of years. We are dealing in defense and aviation, which is our core business. We are dealing with really much more dynamic types of information, which are flights. Now, flights, and this is a depiction of all the flights over the world over 24 hours, a bit sped up, of course. But you see their dynamic information. Of course, the globe doesn't change every day in terms of shape. The magnetosphere changes. There are many things that change. Airspaces change, shading, light, all these things are evolving. And so in order to give the users today the experience that they deserve with the types of tools they have, we really had to change the paradigm, and that's why the presentation was called the death of ETL. I mean, if you try to do what all the other speakers have talked about, whether it's BIM or consulting or mapping huge point clouds of the whole Netherlands, I mean, if you try to do that with the classical architecture, it's going to fail, and that's why the presentation was called the death of extract, transform, and load.
Thank you.